Right, in this video, we're going to talk about 3.1 Objective 2, where we use limit definitions to find equations of tangent lines. We're going to use one of two definitions here. I'm going to use a particular one. You can use either one that you want. Both are taught in this section to find the derivative of a function at a point. The book is going to use the letter A. Other books are going to use the letter C. And so one definition we have is the limit as x approaches a of f of x minus f of a over x minus a. That's the most common way to find the slope of the tangent line at the point A, f of a. So this will be slope of the tangent line at the point A, f of a. Now, there's another more generic formula for f prime of x generically, and that'll be the limit as, and this book uses h. I'm going to use delta x since we're in calculus, so we can get used to seeing delta x. Limit as delta x goes to 0 of f of x plus delta x minus f of x divided by delta x. You may be kind of familiar with this one. Let's just call these h's for now so that it looks like something you did in pre-calculus. I'll change it to delta x's later. And if you wanted to find the derivative at a here, you could take the limit as h goes to 0 of and replace all the x's with a. Like so, and you would have exactly the same thing. So I don't like this definition here. It's a little bit too messy and complicated for me, when this simpler form up here will do just fine. When I want to find f prime of x generically, I'll go ahead and use this form. When I want to find f prime at a particular value of a or c or whatever your textbook calls it, I'll use that form. So two different forms of the derivative for you to know in calculus 1, the one that gives you f prime of x and the one that gives you f prime of a or f prime of c. We're going to be using the f prime of a formula for these problems since we want to find the equation of a tangent line. All right, I've got several problems here. This is going to be a little bit of a longer video. So f of x is equal to 6x. A is equal to 4. Well, the slope of the tangent line here is going to have to be 6. We talked about that in our conceptual video, but let's prove that. Limit as x goes to 4 of f of x minus f of a is 6 times 4 is 24, so minus 24 over x minus 4. That's limit as x goes to 4. 6 times x minus 4 over x minus 4 is 6. Now, since the slope of the tangent line is 6, we can use point slope form. Y minus my y value of 24 is equal to m times x minus my x value of 4. Y minus 24 is equal to 6x minus 24. And as I would expect, because this was a linear equation, my tangent line is my original function. Y is equal to 6x. So f prime was 6, and the equation is y is equal to 6x. Make sure you type an equation in if it doesn't give you y equals. All right, let's look at number 2. We have f of x is equal to 6x squared, and a is equal to -5. So limit as, let's find f of -5 is 6 times -5 squared 6 times 25 is 150. Limit as x goes to -5 of 6x squared minus 150 over x minus a -5. Limit as x goes to -5 of 6 times x squared minus 25 over x plus 5 will give me limit as x goes to -5 of 6 times x plus 5 times x minus 5 over x plus 5. X plus 5s will cancel. Limit as x goes to -5, 6 times x minus 5 is 6 times -5 minus 5. 6 times -10 is a -60. So that's my slope of my tangent line, -60. And y minus my y value of 150 is equal to -60 times x minus a -5. This is y minus 150 is equal to -60x minus 300. Let's add 150 to both sides. We get y equals -60x minus 150. Okay. Moving on, f of x is equal to 2x squared plus 5x. A is equal to a -3. So limit as x approaches -3 of, and then let's stick in a -3. 2 times -3 squared is 5 times a -3. It's 2 times 9 minus 15. That's 18 minus 15 is 3. This will be limit as x goes to -3 of 2x squared plus 5x minus 3 over x minus a -3 will be x plus 3. Let's factor that numerator. 2x and x plus 3. I better have the x plus 3 show up in the numerator. So this needs to be 2x minus 1. So 6 minus 1 is 5. That has to be the common factor to cancel that was giving me my 0 over 0 situation. So limit as x goes to -3 of 2x minus 1 is a -6 minus 1 is a -7. So y minus 3 is equal to -7 times x plus 3. Y minus 3 is equal to -7x minus 21. Add 3 to both sides, and we get y is equal to a -7x minus 18. Okay, clear that. On to number 4. F of x is equal to x cubed. A is equal to 1. So I don't expect you to multiply cubic out all the way. I'm going to show you Pascal's triangle and show you how it can help you here. But f of 1 is going to be 1 cubed is 1. I may not even need, I won't even need all that. I'll just need to do a difference of cubes. Limit as x goes to 1 of x cubed minus 1 over x minus 1. The limit as x goes to 1 of x minus 1 times x squared plus x plus 1. Remember the a cubed minus b cubed factors into a minus b times a squared plus ab plus b squared. It's going to be over x minus 1. Those factors will cancel. Limit as x goes to 1 of x squared plus x plus 1. So 1 plus 1 plus 1 is 3 for my slope. Y minus 1 is equal to 3 times x minus 1. Y minus 1 is equal to 3x minus 3. add 1 to both sides, and y is equal to 3x minus 2. So slope was 3, and this is 3x minus 2. All right. Now we get a different type of function that's got a square root in it. So f of x is equal to 3 over the square root of x. A is equal to 1 over 16. So f of 1 over 16 is going to be 3 over root 1 over 16. It's going to be 3 over 1/4 multiplied by 4 over 4 to get rid of that fraction in the denominator. 12 over 1 is 12. So limit as x goes to 1 over 16 is going to be f of x minus 12 over x minus 1 over 16. And then I'm going to need to make a common denominator here, root x over root x. And that's going to be limit as x goes to 1 over 16 of 3 minus 12 root x over root x times 1 over x minus 1 over 16 is going to be limit as x goes to 1 over 16 of 3 minus 12 root x, and then this is root x times x minus 1 over 16. Let's pull this 3 out. 3 times 1 minus 4 root x. There we go, that'll be helpful. Now I want to multiply top and bottom by the conjugate of that part that has the square root left in the numerator. So I'm going to multiply top and bottom here by 1 plus 4 root x. This is just my technique for this type of problem. 1 plus 4 root x will get me 3 times, and I'm going to be using a minus b times a plus b is equal to a squared minus b squared to help me. So 1 squared is 1 minus 4 squared is 16. Square root of x squared is x. And then I have, I can pull a 16th out here if I need to. Yep, let's go ahead and do that. So root x over 16, and that'll be 16x minus 1 down here. And I have 1 plus 4 root x left in the denominator. So you see that this factor and this factor are very close but are opposites. Let's factor a -1 out of the numerator. And as x goes to 1 over 16, limit as x goes to 1 over 16 is a -3 times 16x minus 1 over root x over 16 times 16x minus 1, 1 plus 4 root x. Those will cancel. Limit as x goes to 1 over 16. Let's go ahead and write this as -3 times 16 is -48 in the numerator. We have root x times 1 plus 4 root x in the denominator. So that will go to a -48 over root 1 over 16 is 1/4 times 1 plus 4 times 1/4 will be equal to a -48 over 1/4 of 1 plus 1 is -48 over 1/4 of 2. 2 goes into 4 2 times. So I'm going to write that as negative 48 over a half, multiply by 2 over 2 is a negative 96 over 1, or a negative 96 for my slope. That was just my slope. So m is negative 96. And my point that we found before was 1 over 16, 12. So let's clear this up. We can write y minus 12 equals negative 96 times x minus 1 over 16. And be y minus 12 equals negative 96x plus 96 over 16. Well, 16 goes into 96 exactly 6 times. So y minus 12 equals negative 96x plus 6. Now we add 12 to both sides, and we get y equals negative 96x plus 18. I think you get the idea after doing this a few times that this is not going to be the way that we're going to want to do this all the time going forward, but this is good practice now to use this definition to help us. Let's go ahead and look at another square root problem. This is a little bit more traditional. F of x is equal to the square root of 5x plus 1. A is equal to 3. Limit as x goes to 3 of f of 3 is 15 plus 1. Root 16 is 4. That gives me the 0.34 that I'm considering. Root 5x plus 1 minus 4 over x minus 3. Going to multiply by 5x plus 1 plus 4 for root 5x plus 1 plus 4, top and bottom. That conjugate there is going to give me limit as x goes to 3 of 5x plus 1 minus 16 over x minus 3 times root 5x plus 1 plus 4 is going to give me limit as x goes to 3, 5x minus 15, x minus 3, root 5x plus 1 plus 4 is 5 times, remember that limit symbol, limit as x goes to 3, 5 times x minus 3 over x minus 3 times root 5x plus 1 plus 4. X minus 3's will cancel. Limit as x goes to 3 of 5 over root 5x plus 1 plus 4. 5 over root 16 was 4 plus 4. It's 5 over 8 for my slope. Y minus 4 is equal to 5/8 times x minus 3. Let's scroll up here a little bit. Y minus, I'll write that in just a second, minus 15/8. So I want this with a denominator of 8. That's 32 over 8. Let's add 32 over 8 to both sides. Give me y is equal to 5/8 x plus 17 over 8. So my slope was 5 over 8. And my equation was 5 over 8x plus 17 over 8. I think we just got 2 more problems, so hang with me as we wrap this up. Y equals root 5x. A equals 5. So y at 5 is equal to root 25 is 5, meaning we have the 0.55 on the graph. Limit as x approaches 5 of root 5x minus 5 over x minus 5. And we're going to multiply by root 5x plus 5 over root 5x plus 5. Limit as x goes to 5 of 5x minus 25 over x minus 5 times root 5x plus 5 is limit as x goes to 5 of 5 times x minus 5 over x minus 5 times root 5x plus 5. And x minus 5's will cancel. Limit as x goes to 5 of 5 over root 5x plus 5 is 5 over 5 plus 5. 5 over 10 is a half for my slope. Y minus 5 is equal to 1/2 times x minus 5. Y minus, let's see, this is 1/2 x, this is 5 halves. Let's write these in halves, which would be 10 halves. So y, add 10 halves to both sides, is equal to 1/2 x plus 5 halves. And then our last problem for today, let's look at this rational function and how we would deal with that. So f of x is equal to 7 over x plus 1. A is equal to 5. F of 5 is going to be 7 over 5 plus 1 is 7 over 6. So that gives me the point 576. Limit as x goes to 5 of 7 over x plus 1 minus 7 over 6 over x minus 5. We're going to have to make a common denominator here by multiplying by 6 over 6 and x plus 1 over x plus 1. This can give me limit as x goes to 5 of 42 minus 7x minus 7 over 6 times x plus 1, and that's divided by x minus 5 over 1. So limit as x goes to 5 of negative 7x plus 35 over 6 times x plus 1 times 1 over x minus 5. Limit as x goes to 5 of negative 7 times x minus 5 over 6 times x plus 1 times x minus 5. X minus 5's cancel, and this will be negative 7 over 6 times 5 plus 1. That's 6 times 6 is 36 in the denominator. So a slope of negative 7 over 36. This is 576, and the slope of negative 7 over 36. So y minus 7 over 6 is equal to a negative 7 over 36 times x minus 5. Negative 7 over 36x plus 35 over 36. I need a denominator of 36, so make this a negative 42 over 36. And add 42 over 36 to both sides. We get y is equal to a negative 7 over 36x plus 77 over 36. And the only factors of 77 are 7 and 11, neither of which go into 36. So that is simplified. And that's it for this video. We'll come back next time and we'll talk about 3.1 Objective 3, where we solve applications involving average and instantaneous rate of changes and derivatives. See you for the next video.